Okay, so now let's talk about direct comparison test. So here is the content for this test. So given two functions, fx and g of x, they're both continuous at the interval, let's see, from a to positive infinity. Okay. And also, you have that fx and gx follows this inequality for all x is greater or equal than a. Okay, so fx is greater or equal than 0, but is less or equal than g of x. Okay, so the direct comparison test says like this. First, if integral from a to infinity fx dx diverges, then integral a to infinity g of x dx also diverges. Okay, so in other words, if the smaller one diverges, you can think about it, it's m-bounded, right? Or let me see that it's you can see this is kind of like a blowout, then the larger one will also blow out. Okay, so this is one, and two, if integral a to infinity g of x dx converges, then integral a to infinity f of x dx also converges. Okay, so that means if the larger part integral it converges, in other words bounded, then the smaller integral a to infinity fx dx will also converge, bounded. So that's the basic ideas. Now let's look at one example here. So let's see example. Let's see if we have integral, let's see, from 1 to infinity cosine square over x squared dx. Okay, and so the integration for this one is not very straightforward, but if we only want to know whether this integral it converges or diverge. Okay, so converge or diverge, we can use the direct comparison test. And how do we do that? Well, here we're going to make use of the properties of this trig function here. So we know that cosine x is bounded by -1 and 1, and also cosine square is going to be from 0 to 1, under the interval from 1 to infinity. Okay, and thus we can construct an inequality relationship, that is cosine square over x squared is less or equal than 1 over x squared. Okay, right, because x squared is also positive, so this is very easy to construct. From here we can get that, well, so this part, this part is like the fx in this direct comparison test. This part act like the g of x in the direct comparison test, which is 1 over x. And we know that integral from 1 to infinity 1 over x squared dx, this integral actually it converges, okay? And also I can show you here it's integral 1 to infinity 1 over x to the power of p dx. So it converges when p is greater than 1. Okay, so this converges. So this is the supporting information for this part. And how do we get this? You can check the previous video I posted. So we know this is converge, and then based on the direct comparison test, so if the larger integral converges, then the small integral also converges. So since this part converges, we can get that integral 1 to infinity cosine squared over x squared dx also converges. Okay, so yeah, so this is a simple introduction about the direct comparison test related with the improper integral. Hope you enjoyed this video, and thank you for watching.